Hey guys, today we're going to talk about indirect measurement. Now before we do that, I'm going to talk a little bit about similar figures. So you can see here that I have two different triangles here. However, they both have the same exact shape going on with them. So if I wanted to, I could take this small green triangle and I could stretch it out and I can lay it over top of the blue one. So for example, if I took this green one and I just stretched it out, I could, if I wanted to, just lay it over top of this, and they should be able to match up with one another. Now, if we notice, they have some sides that link up with one another. So, for example, Y and B. So if you see here that side Y, when I laid it over top of it, it matched up with the B side. X and A. When I laid over the green one stretched out, it matched up with the A side. And then same thing with Z. Oh my goodness. When I took the small triangle and I stretched it out, it laid right over top of the C side. So all I'm doing is matching up the two ends that would lay flat right on top of each other. Now we're going to be using that in today's lesson. All right. Indirect measurement. Indirect measurement allows you to use the properties of proportions to find the distances or lengths that are difficult to measure directly. So a fire hydrant that is 2.5 feet high casts a 5-foot shadow. How tall is a street light that casts a 26-foot shadow at the same time? We want H to represent the height of the street light. So I'm just going to use a cute little matrix here to represent the situation. So in this first box here, I'm going to put the hydrant's shadow length. So you can even look at the picture, you can go back to the problem. You can see that the shadow of the hydrant is 5 feet. I'll put a 5 there. In the box right next to it, I want the height of the hydrant. So you could go back up to the problem, it says it right here, or you could just look at this cool picture. The height of the hydrant is 2.5 feet. The street light now, down at the bottom. I need the shadow of the street light. Again, you could go back up from the problem, it says it right there, or you could look at the picture seeing that it's 26. And then finally, I need the height of the street light, which in this problem, they say H is the height of the street light. Now what we have here is a proportion. So if I wanted to, I could take this 5 over 26 equals 2.5H, and I could solve it looking at the cross products. Looking at these guys, looking at those guys. I'd have 26H is equal to, I'd have 5H is equal to 26 times 2.5. I'm not using a calculator. That equals 65. And then I have a one-step equation. To get H by itself, I could divide both sides by H by 5. Oh my goodness. H is equal to 65 divided by 5, or 13. So the height of the street light is 13 feet. Now I want you guys to try the problem right underneath it. We're doing the same thing. If you want, you can make a nice little matrix, or you can just try to make the proportion. Did you pause the video? Yeah, so pause it now so you can try out the problem. It's like going up top. I hope you paused it. I really hope you did. All right. So at the same time, a 2-meter street sign casts a 3-meter shadow. And then a telephone pole casts a 12.3 meter shadow. How tall is the telephone pole? So there are many ways that we could set up this proportion. One way of setting this up would be 3 over 12.3 is equal to 2 over x. This fraction shows the lengths of their shadows and this one is the actual heights. This row right here are my sign, my shoot sign, and the one down here is the telephone pole. Another example of this that you could have done is, let's do x over 2 is equal to 12.3 over 3. They have the same thing because when I look at their cross products, I will always have 3x is equal to 2 times 12.3 or 24.6. I have a one-step equation here. To get x by itself, I can divide both sides by 3, which is 8.2 feet, right? Meters. Meters. So the telephone pole is 8.2 meters tall. All right. So in this figure, we have two right triangles. Triangle DBA, which is a small one right here, is a similar triangle to ECA, which is the big one out here. So we want to know the distance across the lake, right there. So like we said, they're similar. So if I wanted to, can I click on that guy? I could stretch out the small triangle to overlap the big one. So I can take this purple triangle right here, I can stretch it out, and it should overlap with the big one. Now when we do that, we'll notice that this side right here will overlap with that side there. So when setting up a proportion, I could put small triangle here and large triangle there. I know that the 40 and the regular D would link up with one another. Now when I also stretch out the triangle, this slanted part of the triangle will match up with the bigger slanted up part of the larger triangle. So in the small triangle, that is 320 meters. But for the bigger one, it's not just 162. It is both 162 and 320. So I will have to add those guys together. Or 482. And now that I have my proportion, I can easily just solve it looking at their cross products. Boopity bop. Boppity boop. I'd have 320D is equal to 19,280. Again, simple one-step equation, dividing both sides by 320. I'm calculating it in my head. I'll carry the 1. Oh yeah, 60.25 meters. So the distance across the lake is 60.25 meters. Taking another look at a problem like that. Again, I have two triangles here. I have this small one, and then I have this much larger one. You can see that Michigan Ave, this guy right here, matches up with Kentucky Lane. Well, we want to find out the length of Kentucky Lane. Can I not draw? So when setting up my little proportions here, I can say, again, all right, this is the smaller one, this is the larger one. Smaller one has 6. Well, Michigan, again, matches up with Kentucky. I don't know Kentucky. I'll put X there then. I'll do this one. The smaller part here of Ohio Street, which is 4, matches up when I stretch it out to the entire Ohio Street, which together would be 8. So that smaller part, when I stretch it out, will overlap with the larger part of a higher street. Again, solve the proportion. 4x is equal to 48. Dividing both sides by 4. We know that Kentucky Lane is 12 miles long. 12 miles long. All right, below, I have 4 different problems. I want you guys to try them out. Pause the video. Give them the old college try, and I'll go over the answers here. Oh, by the way, this should say tall. You don't know how to find out how tall it is. It's okay. So pause the video. Yeah, so pause it. You better have paused it, because I'm going over it now. And if you're just going for the answers, I'm having to sub-write your name down. Don't you worry. So for this first one here, I would do 0.45 over 3 is equal to h over 2.2. Oh, this is 0.3, not just 3. Whoopsies. You can look at their cross products. .99 is equal to 0.3 h. Divide by both sides by 0.3. You get that h is equal to 3.3 meters. The one right below it, that h over 50 is equal to 50 over 12.5. Again, looking at their cross products, I'd have 12.5 h is equal to 2,500. Calculating that in my head. Oh, carry the 2. Oh, yeah. H would equal to 200 feet. Moving right over to the one next to that. My proportion would be h over 6 is equal to 7 over 2. Again, looking at their cross products, 2h is equal to 42. Dividing both sides by 2, I get that h is equal to 21 feet. And then this one up here. This is a good one. So we want to find the distance from the park to the house. So here's the park, here's the house. We want to find the distance from those guys. The secret here is to look at these bumps. So here I see I have 2 bumps and 1 bump, and 8 is between those guys. So on the other triangle, again, I'm looking for a number between 2 and 1 bumps. See, 1, 2, 1. So those guys match up with each other. For D here, I see I have 2 bumps and 3 bumps. So I'm looking for a number over here that is between a 3 bump and a 2 bump. Well, I see a 2 bump there. I see a 3 bump here. 5 is between those guys. So to solve for D, there's my proportion. Again, I'm looking at their cross products. I have 4D is equal to 4T. 4D equals 4T. Yeah, that sounds right. Dividing both sides by 4, we get that D is equal to 10 meters. However, that is not the answer to the question. If you go back to the original, it says find the distance from the park to the house. So that is this entire distance here. I need to take that 10 and that 5 and add them together. So my final answer is that the park and the house are 15 meters apart from one another. All right, you have another activity on Schoology. Make sure you get that done. If you have questions, let me know. Okay, bye.